Hey guys, Mr. Marone here. Welcome back in. We are in lesson 10.3, which is our third of 8 in our chapter on circles. So we're going to be looking at what are called tangent lines. And these are a little bit different than what you've seen in the past. The big thing is that tangent doesn't mean the same thing as when we had the tangent ratio in right triangle trigonometry. So we have to kind of put that out of our mind. The idea of a tangent line is a line that only intersects a figure at one point. So when it comes to a tangent line for our circle, it looks like this, where it comes across and it only intersects at that point, right there. And when we have our intersection, that is called our point of tangency. So our point of tangency is right there. And it's simply where our tangent line and our circle intersect each other. And the big thing that comes out of this is in our theorem right here. And that is that if I have a line tangent to a circle, and if I draw a radius from my center up to that point of tangency, they will always be perpendicular. So no matter what, you'll always end up having a right angle right there. And this allows us to utilize Pythagorean theorem, especially if I end up with this third line out to my tangent line through my radius, all that good stuff like you're going to see in these examples. But it allows us to have that right angle in there and give us the ability to use Pythagorean theorem. So if we look at example 1 here, they gave me that CB was tangent, so we automatically can put our right angle. And they want us to find the length of x, or the length of segment CB. If we look closely at this, they gave us the radius was 9. So this radius here is also going to be 9. In other words, OB is going to be the length 15. You can always do that because every radius, no matter where it is in the circle, is all going to be the same length. So if I'm looking closely at this, I've got Pythagorean theorem here. I've got 9 squared plus x squared equals 15 squared. And I've got 81 plus x squared equals 225. And when I work through this, I have x squared equals 144, and x is going to give me 12. Just solving Pythagorean theorem at that point, which I know you guys have done over and over and over again. Go ahead and try example 2 on your own. Remember, AE, you already know the length of that. Go ahead and try this one, and then when you come back in, the answer will be there. Alright, welcome back in. So as you can see here, I set up my 5 squared plus 12 squared for my 2 legs of my right triangle. And then my hypotenuse was 5 plus x. I did not square that, mainly because I'm eventually going to work backwards and take my square root. If we look closely, I did square 5 and 12, and I got 25 and 144, and that gave me 169 as my total. And then when I took the square root of that, I got 13, and the square root cancels out that squared term. So I was just left with 5 plus x on the right. And when I subtracted 5, I got 8 for x. Now, we have a converse of this, meaning the flip of it. And this is if a line is perpendicular to a radius at one point on a circle, the line has to be a tangent. And it's really just saying that this is true both ways. Whether they tell you it's a tangent or whether you have a line that intersects a circle at one point, creates a right angle with the radius, we know we have a tangent. It just kind of flips both directions. So let's take a look at some examples using that, and then we're going to take a look at examples of tangents with a common endpoint. So here you've got 2 examples. They want to know, is KJ tangent to this figure? So in other words, do we have a tangent? If we do, then Pythagorean theorem would work. If this is a right angle, Pythagorean theorem would work. So we can try it. If we assume this is a right angle, I would have 6 squared plus 9 squared equals this whole length, 10 squared. And in order for us to have a right triangle, and in order for us to have a tangent, this has to work. So 6 squared is 36, 9 squared is 81, and 10 squared is 100. And when I combine these, I get 117, which does not equal 100. So no, this is not a tangent. We were able to verify it because Pythagorean theorem was not satisfied. In example 2, it says that segment ST is tangent to circle R. what is the radius. So here, they told us we have a tangent line. We now have to find the radius. So I've got x squared for my one leg and 24 squared for my other leg. And then my hypotenuse is the quantity x plus 18 squared. Since I have an x squared over here, I am going to write this out, or in other words, write it as x plus 18 times x plus 18. 24 squared is 576, and I've got x squared, and then I've got x squared plus 18x plus 18x, so 36x, and then I've got 18 squared, which is 324. Now at this point it looks miserable to solve, but it's very easy, simply because if I subtract x squared over here and subtract x squared here, they're going to cancel. And I'm just left with 576 equals 36x plus 324. Big numbers notwithstanding, it's a very easy thing to solve. Go ahead and solve from there and tell me what you get when you come back in. Alright, welcome back in. So hopefully you found that x equaled 7 after you subtracted 324 and then divided by 36. So the last component to this is if I have tangents with a common endpoint, in other words, outside of the circle. So AB is tangent and AC is tangent, and they share point A. If that is the case, those are the same exact length. They're the same distance away. So in this case, given our setup here, they tell us that AB is tangent and that BC is tangent, so they share point B. That tells me that these are the same measure. So I can say that x squared plus 5 equals 21. I'm going to subtract 5 from both sides, and I get x squared equals 16. And when I take the square root, I get x equals 4 and negative 4. But since we can't have negative measures, my answer is just x equals 4. And that's it with tangents. If you notice, it's a lot of Pythagorean theorem. That's a good thing because you're very good at Pythagorean theorem. If you guys have any questions, make sure to bring them into class tomorrow, and I will see you then. Have a great night, guys. Bye-bye.